Okay, here is problem 4. So nobody asked me to talk about the description, so I'm going to skip that. Some people did ask me to review how do we change it to standard form if this is the transformation. Okay, so what we do is, see how normally this would say f of x, but now it says f of x plus 3. That means that the x is being replaced by x plus 3. So anywhere in my equation that I have an x, I'm going to replace it with x plus 3. So I'm going to do this part first, just going to do this part. So f of x plus 3 means these x's are going to change to an x plus 3. So copying this down, I'm going to have x plus 3 squared minus 8 parentheses x plus 3 plus 13. Okay, so that's the first step. I just did that. The next step is to take all of this and multiply it by a negative 1, just to give you something to do there. So that minus sign means I'm timesing everything by -1. So I'm going to go ahead and put that out here. Everything inside here, the entire function, is being multiplied by -1. And then the last thing is that I'm going to add 2 using my order of operations. Parentheses first, multiply, add. Okay, and then I have to simplify this. So if I multiply this all out, x plus 3 squared gives me x squared plus 6x plus 9. Sorry if I move too fast for you, but you can do it the long way as well. -8 times x, so -8x, -8 times 3 minus 24 plus 13. Okay, I'm going to simplify that. I have, that's my only x squared. 6x minus 8x is -2x. And then I have, let's see, 9 plus 13 is 22. 22 minus 24 is -2. Let me check my answer key that I didn't make any mistakes. Yep, all right, there it is. So I simplified inside the brackets. Now remember, that gets times by -1 and added by 2. It's times by -1 and then added by 2. So now I'm going to distribute my -1. So I get negative x squared plus 2x plus 2, and I still have my plus 2 out here. Put that all together, I get negative x squared plus 2x plus 4. So there is my new equation in standard form. All right, now if we're going to graph it, I actually kind of like to just do it point by point rather than trying to graph this parabola. I'm going to just move each point one at a time. So I'm going to find myself some good points, put some good points on there, and I'm just going to grab and drag those points around using my transformation. So my transformation, again, start inside parentheses. So I'm going to start over here. Remember, inside the parentheses is backwards land. So if it says plus 3, that means I go 3 to the left because it's in backwards land. So I'm going to take this and go 1, 2, 3. Then I have a horizontal flip. Sorry, I have a vertical flip. It's outside the parentheses. I have a vertical flip. So right now I'm up at 6, so I'm going to go down to -6. So I'm here up at 6, I'm going to go down to -6. But then I have a vertical shift of +2, so up 2. So I just moved this point to here. Now I'm going to do it again for this one. I'm going to move 3 to the left, 1, 2, 3. I'm going to flip it vertically, because that's negative is outside the parentheses, so that's anything outside the parentheses is vertical. So I'm going to, right up now I'm at +1, so I'm going to flip it down to -1. And then I'm going to do a vertical shift of +2, so up 2, 1, 2. There it is. Okay, so notice that point is right there. So I'm like going this way. All right, next one, 3 left, 1, 2, 3. Vertical shift, I'm at -2, so that's going to move me to +2. And then up 2, 1, 2. And the next one, 3 left, vertical flip, and up 2. Next one, 3 left, vertical flip, and up 2. And the last, oh, not the last one, 3 left, vertical flip, and up 2. Here's the last one. 3 to the left, vertical flip, I'm at 6, so I'm going to go to -6, and then up 2. And notice when I connect these together, it's still a beautiful parabola. Notice there was no vertical stretch or horizontal stretch. No vertical or horizontal stretch, so therefore it looks really similar. It's just got flipped upside down and moved left and right a little bit. Okay, and given, was this part of this part 2? Or was this part 1? No, it's still part 1, so no calculator. I was going to say, you could put that into your graphing calculator and check and see if they match. But you're not allowed to use a calculator on this, so never mind. So there it is. That was question 4.